You walk into a used bookstore, and there it is, that smell. Warm, a little sweet, a little woody. People call it comforting. They call it nostalgic. But here's what's actually happening in that room. You're smelling a book come apart. That scent isn't a memory, it's chemistry, and more specifically, it's decay. Paper looks like one material, but it isn't. Most pages are a network of 3 long molecules called polymers. Think of a page as a forest, and each fiber in that forest as a rope made of smaller threads. Cellulose is the main thread. It gives the fibers their strength. Hemicellulose glues those threads together. Lignin stiffens the walls, especially in cheaper wood pulp paper, which is why that paper feels rougher and yellows faster. On top of those sit sizing and fillers, and in older books, whatever the papermaker happened to add. Those 3 polymers are the skeleton of the page. Like any skeleton left to time, they're slowly coming apart. 2 quiet processes do the damage. The first is acid hydrolysis. Water in the air teams up with acids to snip the long polymer chains into shorter pieces, the way scissors cut a rope. The second is oxidation, where oxygen slowly attacks the same chains from the side. Every break, every chain that gets cut, sets a small volatile molecule free. Volatile means it floats, and that's the whole trick. A full polymer chain is far too large to lift off the page and reach your nose. Only small, broken-off fragments can. So the existence of the smell is proof that the big molecules are being cut into little ones. You can't smell an intact book. You can only smell one that's already started to fall apart. You can read that scent molecule by molecule. The vanilla note comes from vanillin, released when lignin breaks down. The almond note is benzaldehyde, another lignin fragment. The faint, bready, almost caramel note is furfural, which comes from hemicellulose. The sharp, slightly vinegary edge is acetic acid. The grassy, woody undertones are aldehydes like hexanal, products of oxidation. Every familiar note in that comforting smell traces back to a specific part of the page and to a specific way the page is failing. Here's the most elegant part of the whole thing, and it explains why the smell is sweet in the first place. Lignin isn't built from plain chains. It's built from ring-shaped aromatic building blocks, the same family of structures that gives spices, smoke, and flowers their smell. When lignin falls apart, it releases aromatic molecules, and aromatic molecules are exactly what your nose registers as vanilla, almond, and spice. Cellulose, by contrast, is a simple sugar chain, and when it breaks, it makes relatively bland molecules. The character of the old book smell comes so heavily from lignin because lignin is the page's most complex ingredient, and complexity is what your nose finds interesting. Wood pulp books, loaded with lignin, smell far more than old ragpaper books for the same reason. Listen to how people describe it. Chocolate, coffee, vanilla, grass, a cigar box. Those words sound like poetry, but they aren't random. Each one points at a real family of molecules, because paper only has a handful of breakdown routes, and every book takes more or less the same ones. Old books smell alike even when they came from different countries, different printers, different centuries, because the recipe for the smell is written into the paper itself. Your nose barely needs any of it to notice. Odor thresholds for compounds like vanillin sit at vanishingly small concentrations, far below anything you could weigh. So a book that has lost only a tiny fraction of its structure already announces it to anyone who leans in. A new book smells completely different for the opposite reason. It smells of glue and ink and sizing because its polymers are still intact. It hasn't been degrading long enough to release the old book cocktail. The smell itself drifts over a book's life. A freshly printed page is all glue and ink. As the first decades pass, the sweet lignin notes come forward. As the paper grows more acidic, the sharp acetic acid edge strengthens, and researchers watch that signal closely, because acidity accelerates everything else. The smell you love only appears after years of slow, invisible breakdown, and it never really stops. Now the part most people miss. Some books smell a lot more than others, and the difference is a fingerprint of how the book was made. Before the middle of the 19th century, paper was made mostly from cotton and linen rags. That paper is nearly pure cellulose, low in lignin and low in acid, which is why a 300-year-old book can still look almost new. Then, paper makers switched to wood pulp and sized it with an acidic compound that helped the ink sit still. Wood pulp is full of lignin, and the acid never really leaves. So, books printed after the 1850s have been slowly eating themselves from the inside, releasing far more of those vanilla and almond molecules as they go. By the late 20th century, libraries had a name for the result. Shelves of 19th century books were turning brittle and crumbling under their own weight, a slow chemical fire that no flame ever started. Heat and humidity speed the whole thing up, which is why archives are kept cool and dry. The famous smell of an old library is, in part, the smell of a 19th century manufacturing decision. Which is why the smell is more than atmosphere. It's data. And here's what that means in practice. Because the molecules track how far the degradation has gone, the smell of a book reflects the condition of the paper itself, molecule for molecule. In 2009, chemist Matthias Sterlich and colleagues at University College London collected the air above old books, sorted the molecules with a mass spectrometer, and showed that the mix tracks how degraded the paper has become. They called the idea material degradomics, reading the smell of an object the way a doctor reads a blood sample. Traditional tests usually need a small physical sample torn from the page. This one needs only the air around it. It's early-stage work, not something libraries do on a shelf-by-shelf basis yet. But the principle already holds. A conservator could judge how fragile a book has grown without touching it, just by what it's quietly giving off. The smell isn't just something you notice. It's something you could, in principle, measure. So the next time you open an old book and breathe it in, you're not just enjoying a smell. You're reading a chemical record, decades in the making, that scientists now know how to decode. That warm, sweet, slightly woody scent is the book's own decomposition, written in the air. Every old book is quietly announcing its age. You've been listening to that message your whole life without knowing what it said.
This is Reasonable Wonder. Big questions, clear science.